I will be explaining how to predict whether a spontaneous redox reaction occurs or not. There are two ways to do this. Both involve using the table of standard reduction potentials of half cells. I've drawn up a shortened version of the table here. And how the table works is, as you go up the left side of the table, there's an increasing tendency to reduce, or to gain electrons. And as you go down the right side of the table, there's an increasing tendency to oxidize, or to lose electrons. Now, the first method is to simply check the positions of the reactant species on the table. If both reactants are on the same side, then there will be no reaction. If there is one reactant on the left side and one on the right side, there are two possible scenarios. So, a good thing to do is to identify the oxidizing agent and the reducing agent. Then you check to see if the oxidizing agent is above the reducing agent. If it is, then there will be a spontaneous reaction. However, if the reducing agent is above the oxidizing agent, there will be no reaction. As an example, we are told to predict if a spontaneous reaction is expected when the following is mixed: copper and mercury. So, you want to first identify which one undergoes oxidation, which one undergoes reduction, to see which agent they are. So, copper gains 2 electrons to become copper, neutral copper. And mercury loses electrons to become mercury 2+. So, because copper gains electrons, it undergoes reduction, which means it's the oxidizing agent. And if copper is the oxidizing agent, then mercury must be the reducing agent. And as we can see, mercury loses 2 electrons, which means it undergoes oxidation, which means it's the reducing agent. And if you check on the table, you'll see that mercury is higher up on the table than copper. And this means that no spontaneous reaction occurs, or there's no reaction. Now, something to note about hydrogen is that if it's present, like in this following half reaction, then hydrogen must also be one of the reactants present. So for example, if sulfur were to react with zinc, the question would have to state that hydrogen is present. So if you look on the table, you'll find sulfur on the left side of the table, which means that it is the oxidizing agent. And you'll find zinc on the lower right of the table, which means that it's a reducing agent. Now, since sulfur is higher up on the table than zinc, technically you would think that this reaction is spontaneous. However, the question never says whether or not hydrogen is present, and you cannot make the assumption that it is indeed present. You can only assume that there is no hydrogen present, which means that there is no reaction, because hydrogen is one of the reactants and it must be present in order for the reaction to occur. So, for this question, no reaction occurs. Because there is no hydrogen present. Now, if the question instead said, would adding zinc to acidic sulfur result in a spontaneous reaction, then the answer is yes, because the question states that sulfur is acidic, it means that hydrogen must be present. So, there is a spontaneous reaction. moving on to the second method, it involves the standard reduction potential, which is measured in volts. They are the numbers you see at the very right of the table of standard reduction potentials of half cells. Now the O in the over E indicates that the electrochemical cell is at standard state. Now, in order to predict whether a reaction is spontaneous or not, you must calculate the potential of the cell, or net potential. To calculate this, you must add the standard reduction potential values of the reactants together. Do note that the oxidation reaction will have the sign of its standard reduction potential value reversed. Now, if you add the two values together and the resulting net potential is positive, then the reaction is spontaneous. If it is negative, then there is no reaction. And this is because if the net potential is negative, then you must put work into the system in order for the reaction to occur. So, for example, we are told to calculate the net potential of this cell, which consists of lead and manganese. And we are told to state whether the reaction is spontaneous or not. So, a good place to start is to write out each half reaction. So you have lead, 2 electrons. So lead gains 2 electrons to become lead, neutral lead. So because it gains an electron, we know that it undergoes reduction, which means that lead is the oxidizing agent. Then we write out the half reaction of manganese, which is, it loses 2 electrons. And because it loses electrons, it undergoes oxidation and is therefore the reducing agent. So now you look at the table to get the standard reduction potential values of each of lead and manganese. So E value for Pb2 plus is negative 0.13 volts. And the standard reduction potential for manganese, on the table it says it's negative 1.19. But because manganese is the one that undergoes oxidation, that means you must reverse the sign of this. So you reverse the sign so it's instead positive 1.119 volts. And to calculate net potential of the cell, you add these two values together. So you have positive 1.19 volts minus 0.13 volts equals positive 1.06. Because the value of the net potential of the cell is positive, you have a spontaneous reaction. And that wraps up how to predict spontaneous redox reactions.